Review video number 3, linear equations recap. So this is just to sum it all up. There are 3 forms of linear equations. One is a table, the other is a graph, and the last one is an equation. Here I've drawn a table. Now, you should be able to tell if it's linear or not based on the table. Linear functions have the same rate of change, a constant rate of change. We compare the y's over the x's, the change in y over the change in x. The change in y here is plus 2. The change in y here, again, is plus 2. The change in x's is plus 1, plus 1, plus 1, and plus 1. Now I can see that the change in y, 2, over the change in x, 1, 2 divided by 1 is 2. Again, 2 divided by 1 is 2. And so if I know that this is a linear equation, then I can predict the next y values. I'm going to add 2 again and get 3, and add 2 more and get 5. So this is a table form of a linear equation. Now a table is just a different way to write ordered pairs. So this really says -2, -3 is an ordered pair, and I can graph that. -2, -3, -1, -1, that's another ordered pair. 0, 1, 1, 3, and 2, 5. So I've plotted these points on my graph, and I can connect them with a straight line. You'll want to use a ruler and put arrows on the end. Now we've already talked about how to write the equation from a graph. Okay, so you look at the y-intercept. It's 1, and here it is on the table. So I know that b equals 1. And I can find out the slope too. Now we did that in the table. Rise over run. 2 divided by 1 is 2. Or I could look at any 2 points on my line and do the triangle, the slope triangle. So up 2, right 1. 2 divided by 1 is 2. I'm writing the equation in y equals mx plus b form. So 2x plus 1. I could have done the same thing from the table. The slope is 2 divided by 1, which is 2. And the y-intercept, remember, is when x is 0. My y value is 1. So I get the same equation. 3 forms of a linear equation. That almost fell. Okay. Relations versus functions. So these are a couple definitions you need to know. A relation is a set of ordered pairs. A function is a special kind of relation where the x's, or the input values, do not repeat. Here's a mapping diagram. This says 1 maps to 3 and 4, and 2 maps to 5. This could also be written as a set of ordered pairs. It's just a different way to display it. 1 maps to 3, 1 maps to 4, and 2 maps to 5. You can see that the x values of 1 repeat. So this is not a function. It is a relation, a set of ordered pairs. Here's an example of a function. 1 maps to 5, 2 maps to 4, and 3 maps to 6. You could write these as ordered pairs. The x values do not repeat. That makes it a function. It's also a relation. Every function is a relation, but not every relation is a function. Sometimes we're not given the set of ordered pairs. Now, if we are given a graph, we could make a table, or we could list out the ordered pairs and then decide whether it is a function or just a relation. Another question that you could ask is, does it pass the vertical line test? And we abbreviate it VLT. The vertical line test says that if you take a vertical line, that's this way, vertical line, and slide it from left to right across the graph, that it will only touch the function once at any given time. So, vertical line test, here it passes the vertical line test. It only touches once at any given time. So yes, this is a function. Here's a circle. If I slide my pen through it, it touches twice. It touches here and here simultaneously at the same time. It touches here and here at the same time. Here and here at the same time. It does not pass the vertical line test. So no, this is not a function. And the last one, this is a parabola. It's a U-shaped graph. It's symmetric. And if I slide my marker through, it only touches the graph once at any given time. For each x value, there is only one y value. So yes, this is a function as well. And linear versus nonlinear. So just because something is a function does not make it necessarily a linear function. The last example you saw two graphs that were functions, but both of them are not linear. So here I have a linear function. By definition, a linear function makes a straight line. A straight line, linear function. It's easy to tell if you have the graph. If you have a table or a set of ordered pairs, you will need to check to see that it has a constant rate of change, meaning it has a constant slope. Here's a nonlinear function. It's a function, but it does not make a straight line, nonlinear. I wrote down all of the ordered pairs from this line, -1, -4, 0, -2, etc. And I've shown you the change in y. It's going up by 2 each time. And the x's are going up by 1 each time. Rate of change means change in y over change in x. 2 over 1 every time gives us 2, which is the slope. However, I've written down the ordered pairs for the nonlinear graph, and you can see they go down 3, down 1, up 3, where the x's go up 1 every time. If I do -3 over 1, -1 over 1, 1 over 1, or 3 over 1, I don't get the same answer every time. This is nonlinear. It does not have a constant slope.